Let's get started. For those who missed the first video, let's do a quick recap on how I designed, simulated these in a 3D app and then built them. So the first thing I did was design in Fusion 360 what I call stick figure. It's a simulation to just look at the movements and moments of all the parts to the landing gear. Make sure they did what they were supposed to do. So pretty much pop a spring in. We get it down. I've cut a little slot. This is pretty rubbish right now. I have to try and get this guy in. These are all just temporary bolts and stuff. It's just all test fitting. We when we did the destructive test, we didn't have this sliding slot here, which there we go. I don't have the arm in. So then the next thing is we pop the arm in here. Again, these are all the wrong screws and so forth, and I'm just really doing a quick assembly of this. This is all in PLA, as I've said before, and gosh, it's awkward. Should have done it without the wheel on it. There we go. So these are just for testing, for motion plus destructive testing. I've been looking into wanting to do this in resin, on my resin printer. I got a new resin printer. It's real cool. Prints real fast. And it's going to be more accurate dimensionally. This is, like I say, it's just a cheap PLA, but it's real tough. And we've got a flat spot here, and we've got a flat spot here. This goes in and self-aligns, and everything looks rosy. Then this should go onto the pin here. So retracting, oops, forgot my spacer, but anyhow, retraction would go like, from 90 degrees to fully folded in. These gear I use are really tough and very reliable. So that's how I assemble it. It's pretty darned easy, to be honest with you. And the way this works for steering is there's a grub screw here which goes through into a flat spot on the pin. I then put some ball links, those, the ones with the threaded rod in them. I put them on here. Then ball links go through piano wire to the steering servo on a slip type function, and it works absolutely fabulous. So there's the landing gear, and that stop works real well. I have adjusted it slightly so it doesn't go as far down. I do need a stronger spring. This is about, I don't know, maybe 5 pounds. I probably need at least a 10 pound for the nose. It's gonna work just great, I think. 3D printed. This is done in PLA, and it's printed lengthwise like this for strength. If I did it this way, then it would be very weak on the strut here. So it compresses good. It's just all temporary. That's why the screws are all shitty looking. But it's pretty much to scale. So we're going to do 20 smackdowns to simulate a landing. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there's absolutely, surprisingly, no damage. So I think we're going to now try and do like a simulated crosswind landing. So I'm going to sort of try and hit it like this. And this is, if it's going to fail, I think it's going to fail like this. So I am actually quite surprised at the abuse this thing's taken. What do you think, Brad?
Yeah, it's holding up good.
Yeah. So that's now about 40 to 50 that we've done on this, right?
Yeah.
Total. And it's absolutely holding up. See, there's absolutely no damage to this thing. And this is just a cheap PLA for the PLA printer. And even the strut shaft here is PLA. Now, obviously, I would change this to metal. Could a slot in here with a bolt so that, you know, it has its length held. And I'm actually pleasantly surprised. Now, there's no fill in this. This is 100% solid, and the temperature is 205 degrees C that this was printed in, because I found that 205 and a 60-degree bed literally welds each layer together, and there's absolutely no separation. I would have thought these little knuckles here would have come flying off.
We need to see if the holes are elongated on the gear.
What, here?
Yeah.
Yeah, no, nothing at all. Nothing's moved, and frig, I'm actually very surprised. And that's how it starts off, is on this angle, and that's done scale, by the way, off the real aircraft, using side photos and whatever. And we just arbitrarily picked a spring and stuck it in there, and this is 5mm, which is the pin size for our retracts, which we've used on the Eurofighter, the A6, and the Tucano. And my Eurofighter and A6 was somewhere between 22, 24 pounds flying weight. So the gear itself with a 5mm pin doesn't have a problem, and has been very successful over the last 12 years. So this may work. I think putting a band around this, you know, like a hose clamp type thing or something like that, where the pin goes in, is probably required. And this being some kind of metal, maybe machined aluminum, put a brass sleeve in. So I'd have to rescale everything so that we have a nice, you know, sliding sleeve here. But this in metal will work out great. So anyhow, that's, I believe, a 65mm wheel, which is scale. Or it's 60 at least. So it's close enough right now. And I need to adjust the shape and the design of this so it's exact scale, make it beefier here so it looks better. I think we'd be golden. So anyhow, back to testing. And this is nose gear, by the way. The mains are much beefier and bigger, and by about maybe, I think, 15%, something like that. So if this one works, then the main should work. And I mean, I was really hitting that, so I'm pretty damn impressed so far. And this, so far I'm pretty impressed, and this is our first design. And if it can withstand pounding on the bench like that, both, you know, kind of sideways to simulate a crosswind and whatever, I'm pretty sure it would hold up in a plane. But we've got some cheaper planes that we can test it on, so no problem. Anyhow, there we go, guys. It seems to work.